So you should have this G-charts repository. It should be in your readers tab. Go and find this. We're going to start with the module 1. And as I explained, we'll start with the A script. Whatever I'm doing, it's already there in the B script, right? And then at the end, you'll have an exercise that you can do. I'm assuming most of you have a good background on Earth Engine, so I might gloss over certain processing things. But if you feel that I didn't understand why did you use this function or what does it do, please ask. Right? All of you might be at different levels of Earth Engine, so if something doesn't make sense, please stop and ask. I'm happy to explain that. So starting with this first script, the dataset we'll be using is called TerraClimate. This is the data. It is available from 1958 to current, right? And it's a monthly data. So you have monthly values of different variables at a pretty high resolution. So about 4 kilometer resolution. And this is pretty high for climate data. Typically climate data have 20, 25 kilometer resolution. So this is pretty high. This is based on the CRU climate data. So it is a process from that. You have different variables. If you're working on water resources, this data is cold. There are a lot of variables that are not easily available elsewhere. So things like AET and PET, evapotranspiration, you have drought index, you have runoff and precipitation that is available for last 70 years, right? So again, very useful data to do trend analysis. We'll work with temperature time series. We'll plot the maximum and minimum monthly temperature. So what this is doing is at each pixel, it is saying for this month of this year, this was the average temperature, average maximum and average minimum. And it'll give you that value. This data set also needs some pre-processing. You can see there is a scale value. And this happens with many data sets in remote sensing, right? You get the data and you have a scale factor. So if you loaded this value and inspected the pixel values are not degrees Celsius. Though the units of this will say degrees Celsius. If you inspected a pixel value, it might say 200, right? And you would say, wait, what is this 200 value, right? And the 200 is not degrees Celsius. You have to multiply it by the scale factor to get the degrees Celsius. So if your value pixel value says 200, you need to multiply by 0.1 and get 20. That's the value. And can anybody tell me why do we have scale factors? Why don't we just get an image directly with the pixel values? Anybody knows why we have to do the scale factor? And this happens everywhere. So go ahead. If you look at the Sentinel data, they will also have a scale factor. You have to multiply the value by this to get the reflectance. So why do we have scale values? Yes, somebody who had an answer. It takes less data storage space to store values as integers. So if you want to store a value like 25.6, you have to store this as a floating point value. It takes 64 bits to store that one value, minimum. But if you want to store a value like 256, integer, you can store it in the 16 bits. So 4 times less data storage to store the pixel value as integer versus as a floating point. So Sentinel-2 generates 5 petabytes of data every month. So imagine if they give us the value as integers, they can consume 5 petabytes. Otherwise, if they wanted to give us as floating point, they would store data as 20 petabytes, right? So let's say users can convert the values to floating point values. So that's why most data sets will have the scaling factor that we have to multiply ourselves to get the values. So let's plot this temperature time series here. So we start with a geometry. We have put a point here. You can also do a polygon. Let me just delete this and then just do a polygon just to make it easy. So let's say I have this city. I want to know the average temperature within this polygon. So I have a geometry. TerraClimate data has many bands. We just select the TMMX and TMMN band. So these are the temperature band we want to plot. We want to apply the scaling factor. So remember, our entire data set has one image for every month for each year. So we have to map a function. So we map a function where it takes each image, multiplied by the scaling factor, and return the image. So when you multiply the image by some vector, this generates a new image. And when you generate a new image, it doesn't have any metadata. So whenever you're doing any processing like this, you should always have this copy properties function. It says, I'm creating a new image. I want to copy some metadata from my original image. Each original image might have a lot of metadata. And here we are copying at least this one property called system:timestamp. For any charting in Earth Engine, you have to have at least this one property, which is the timestamp of the image. So the date of the image. So we at least copy that. And if there are other properties that you want to copy, you can also specify that in the list. And finally, we just specify start and end year and filter this. So now we have this filtered collection. You can see I have my filtered collection, which is the Terra climate image for 1 year, which we have taken. So we have 12 images. We have selected the 2 required bands for our plotting. So we have the MMX and MMN, and these are all scale values. So if I add it to the map, they will be the actual values in Celsius, degrees Celsius. Okay, so we have selected those 12 images, and now we want to know what is the trend of temperature over 1 year in 2022 for this region. So let's create a chart. We go to the docs. We have the UI function, UI.chart, and we have the image functions. So you can see there are the image time series functions here. This is the function UI chart image series. All right, so we have the 12 images. Let's plot those values. We'll use this function UI.chart.image.series. This will plot the values of each band at each time step and give me a time series chart. So we'll start typing. You can use autocomplete in Earth Engine. Control plus space is the autocomplete shortcut. So I can do control space and just use my arrow keys to pick the correct function. I don't have to type it. And once I autofill this, I can also do control space again to autofill all the parameters. Right? This is a very useful way to write your code, so you don't have to refer to the documentation all the time. Many of you might be coding by just specifying each parameter here, saying this is the image collection, this is the region. Don't do it. This makes your code very hard to debug. Also, for you, if you come to this code, it's like, what is this parameter? I don't understand. Instead, Earth Engine supports giving the parameter as a dictionary. So I'll open the dictionary and I'll give each parameter with its name, so that I understand that this parameter is for my image collection, this parameter is for my region, and so on. So what image collection we want to plot? Filtered. This one has 2 bands. Remember, we have these 2 bands of each image. Let's select one of the bands for now. Let's just plot one band. So select TMMX. Region. What region do you want to plot? We have a geometry, which is a polygon here. Now, when we create a chart, this region would have probably 10, 15 pixels. What value do we want to plot? There are 10, 15 different pixels of values inside of this. And in the y-axis, we can plot only one. So what reducer? How do we take those values and plot? Since this is the climate data and we are having a region, we can just say mean, give me the average value. So what you see on the y-axis is the average value of the temperature in that region. Okay, you can use any reducer here. We'll use the mean one. Scale, what is the resolution? Again, each Earth Engine dataset will mention the resolution in the dataset description. Just use this resolution from here. Okay, whenever you need to give scale values, go to the dataset description and use that. X property, what should be in the x-axis? The default is your timestamp. So we'll just skip that. Right? And we have a time series chart. Let's print that. And this is our chart that came out of this. So you can see January 1st, 2022, in this city, the temperature was 29 degrees, the maximum monthly temperature. And in summer, it goes high, and then it goes down in winter. Right? So this is the time series chart that we can create. So in Earth Engine, this plot is called a series. Right? So you have one series on your map. So one y-axis value. You can have multiple y-axis values for each x-axis value. And the way to do this is in Earth Engine, whenever you feed yourself wanting more than one line, that means each line has to be a band. So here we selected one band. One band means there's one y-axis. I can select both the bands. So I say I want both MMX and TMMN, right? I want both the bands. That means I'll get 2 lines. one for each band. So now we want to customize this. We want to generate a chart that can be readily used, especially we want to customize the labels, the charts, we want to customize the y-axis, title, maybe we want to have color, data points, and so on. Right? Let's see what we can do. But before that, I want to just highlight what happened here for you to understand that when we plotted this, we had an image collection. And we had an image collection and we had a geometry. How did we get this chart? Earth Engine said this function took your image collection, extracted the value within this geometry from each image. There are 12 images. It extracted the average value within this polygon for each image, generated a table, and sent it to the chart API. And if you want to see the table, you can pop this chart out. And if I say download CSV, you can see the table that got generated is this. You can see the CSV when you download it. This is what is generating the chart. This is what the Google chart tools are seeing. So we had each timestamp, and for each timestamp, we had the min and max value. So ultimately, this is what was sent to the chart tools to create the chart that you see here. So the job of this function was to take your image collection and turn this into this table. Right? Remember that. And whenever you find yourself that I want to do X, I don't know how to do it, well, you just have to create this table. And once you create the table, you can now use the chart tools. Okay. I want to switch back to the presentation to see how we can customize these charts. There are three main functions to customize the charts that you generate. First one is called set options. Second is set chart type, and then set series names. So set options allow you to customize a chart from the Google chart tools. So if you say, I want to now customize the legend, how do I do it? Well, you go to Google chart tools. I've linked to the documentation there and say, how do I customize legend using Google chart tools? And whatever options you see, those are the options you'll use in Earth Engine. Right? So all the options come from Google chart tools. They are called something different. If you use the different charting functions, they will be called something different. So let's learn what are the terminology that Google chart tool uses. This is a time series chart. You can see we have multiple time series. This is a chart from the dynamic world dataset showing the class probabilities over time at one region. Right? So if you have a chart like this, what does Google chart call? It's different things. You have the title of the chart. If you want to set the title, you say, change the title to be this, or set the title name to this. This is called the legend. Simple enough. This is, you can control the placement, what goes in the legend, and so on. Each individual plot line is called a series. This is very important, where you say, I want 2 lines. The Google chart terminology is that each one is a series. So if you want to now control the color of each line, the style of each line, you have to say series 1, line width is this. Series 2, point size is this. Series 3, color is this. You can also say color equals this. That means all the series will have the same color. If you want to customize, you can say series 1, 2, 3 have different values. The y-axis is called v-axis, vertical axis. Each individual value are called ticks. So if you say, I want to have one label at every 0.2, so 0.1, 0.3, and you have to say, how do I customize my v-axis ticks? That's the terminology they will use. The grid lines are the kind of lines that you see in the chart area. Similarly, you have h-axis, which is horizontal axis, and all the labels are called ticks. So if you say, I want to change the label to be every alternate month or every 6 months, how do I change that? And then you should say, I have to set some ticks for my h-axis. Okay. So these are kind of the basic structure of the chart. And whatever chart customization options you have, you need to use those to customize that. Once you create a chart, each chart function will generate a specific kind of chart. So when you run, say, time series chart, you got a line chart, right? You get a line, but you can change the chart type to be any supported chart. So there's a function called set chart type, which you can use and set the chart to be a different type. You have line chart, which is a time series chart. You can also change it to be a scatter chart, pie chart, area chart, bar chart, column chart, histogram table, and so on, right? So these are different charts. So each function will generate some chart. You say, I don't like this, I want a bar chart. Well, you just set it as a bar chart. Right? So this function will change the output chart type that it generates. Again, there are other advanced chart types, which we'll cover in the module 3 as well. And finally, there's a function called set series names. By default, the names of your each series, each plot will be coming from the bands, right? TMMX, TMMN. If you want to change the name, saying that this is maximum, this is minimum, you can use the function set series names. Okay. So 3 functions for customizing. You have set options to add all the Google chart options to customize your axis and charts and title and label. Chart type to customize chart type, and series names if you want to change the default names of the series. Okay. With that, let's just go back to our code and say, I have this chart. I want to now customize it. Okay. I want to make it all looking nice. So I'm going to copy this whole thing and show you how to customize it. So let's first take this one chart and we customize it. When I'm doing the customization, I generally like to do it one step at a time. So again, when you're doing this, add one step, see how your chart changes. So if we create a chart, you can immediately just call the function. So first we'll just say, call this function set chart type. What chart type you want, right? Anyway, the default is line chart. So we just set it to line chart and it'll just generate this chart. If I change it to say column chart, you can see the same chart is now plotted as a column chart, right? So this is what the set chart type does. Same data, you'll get a different output. Let's continue with the line chart. This is what we want as a time series chart. The second one is the set options. You have to give a dictionary of all the parameters for customization. And this all comes from chart tools. So let's just try with this. We'll just do title. We'll just say monthly. Right, that's a title. And let's run this. By the way, you can use Control plus Enter to run your script. You can see I'm not reaching out to run this. I can just do Control Enter to run this. Very useful to just type the code, run this, and do this. So you can see now my title has been changed to monthly temperature. I can also set the title of the different axes. Remember what the axes are called? V-axis is the vertical axis. And whatever you want to customize inside V-axis, you need to give as a dictionary. So we'll say V-axis, I want the title to be temperature in Celsius. Okay, so my V-axis gets customized. So you can see my temperature is labeled here. I can give H-axis and we'll just say title. No, I don't want any title here, right? So I just say any title. We can also customize the format. You can see the default format is March 22. Earth Engine, Google Chart Tools has different date formats that you can use. So let's say I want to keep the labels as YYYY, MMM. So now you can see my labels of the time would be 2022 March. So I could change that, how the dates are represented. Next, the question on line width. So first, let's set the line width to be 1 and point size to be 2. So point size is the individual dot of the data point. So you can see now my width is less, my point is more. Okay, so we could do this, and we have 1 series, so we could do this. Now let's just change it to be 2 series. Now we have 2 series. And both are plotted with the same line width and point size, and they are assigned some color automatically. I want to customize it. I want this line to be having a larger point size. How do I do it? So you can have a default, which will apply to all series. If you want to customize each series, you can say, I have a series parameter. The first series is called series 0. Second one is called series 1. Okay, so counting starts from 0. So I say first series, my point size is, let's say 0. I want to just turn off the point size. No points for series 0. Okay, and for 1, I want to say line width is 5, whatever, right? So now I have a custom option. So each series will be now plotted using those options. Right? And this is helpful if you have say 12 bands and you just want to highlight 1 band, right? So you have a default for everything else, but for the one you want to highlight, you can override that customization. You can also change the color. So I can say this one will be green color. You can see it's plotted in a green color. Right, so you can specify series specific options for each of those series as per your requirement. Right now, I'm just going to keep this and just change the color. I'm going to make the series 0 color red. And this one. Remember, the series are sorted alphabetically. So the MMX and MMN, the order of which they'll be plotted are alphabetical. So here you can see this one is red. Series 0 is red, which is the MMN, because MMN comes first alphabetically before MMX. So if you want to assign the correct colors here, I have to do this. Series 1 is this red and series 0 is blue. That will give the correct color. I want a red color to be higher temperature, blue color to be lower temperature. And this is one of the pitfalls when you, whatever order of your bands, the output will always be sorted alphabetically. I also, instead of, you can see my legend also has the band names. So instead of doing this and changing the band names, I'll just like to use the select function. The select function has 2 parameters. So let's say it's a select function. So if you have an image collection, and the select function has 2 parameters. Select the bands, and then the second parameter, which is new band names. You can actually rename the bands right when you select them. Super helpful. So I say select these 2 bands, and I give the second parameter saying rename them to be maximum and minimum. So this does 2 things. One, I have readable band names. So my legend will have maximum and minimum instead of TMMX and MMN. And I can have control over how I name them, so it's sorted accordingly. So now when I run this, you'll see my legend will automatically update and it'll have maximum and minimum. And now I have a chart that looks correct. So you can see now we went from this one to this one. This one, you would be pretty happy to include this in your app or in your publication. You can pop this out, download this PNG file, use this in your presentation, or download this in SVG. If you want to say, I want to further modify this in a graphics software, you can download SVG, which will be a vector file which you can edit. Or you say, I really like to do this in Python or other software, download the CSV with the data table. You can use that table and plot this in any other software. So this is the Google Charts documentation. So if you go to search for Google Charts docs, so this is the documentation. If you go to the guide here, there is one guide for each type of data plot. So if you say line chart, if I go to the line chart documentation, and this kind of shows you how to create different line charts. Again, it's documented step by step, all the parameters here. All the other parameters, you can see configuration options. All of these are here. So there's aggregation target, animation duration, whatever, chart area, colors, crosshair, again, a lot of these parameters. So each, you can use any of this position. So you can say, I want to now customize the H-axis text position, how it is placed, outside, inside, whatever. You can customize it. So all of these charts will have so many of these parameters which you can use. So this is the documentation, or just search for Google Charts, and whatever chart type you have, each type will have different things. Like for example, pie chart will have options for customizing each pie of the pie chart and so on. Right? So go to the chart type that you want and you'll find the documentation. We'll be covering a lot of those. So most common type, you'll kind of get familiar with those. But again, whenever you say, what more can I do? And you can go to the documentation, you will find some stuff that is interesting and it will find the way to do this.